Good evening, everyone. Thank you for making it out on a Thursday at 5:30, a few hours before the big replay party afterwards. My name is Nikhil Swaminathan, and I'm a product manager at AWS Mobile. And today I'm going to be talking to you about building an Android app from beginning to the end. So what I'm going to do is I'm going to take a simple app, cloud enable it, then build it in the cloud, and then actually show you how to share it with testers. All right, so first, a few trends for the mobile industry. Over 1.6 trillion hours were spent in 2016 tweeting, posting on Facebook, snapping, swiping left, swiping right. And that number is projected to keep growing to about 5 trillion by 2021. Enterprise adoption. A lot of enterprise players are now building apps. An average of six apps where enterprises had an average of 6 apps within their company. And over 50% of them are actually experimenting with a lot of different web technologies. One of the big trends we've seen is in JavaScript. 66.7% of the people survey respondents on both Stack Overflow and GitHub have claimed that JavaScript is the language they use. So JavaScript has become a very common programming language. So clearly the opportunity for mobile apps is huge. I mean, there are over 4 million apps in the App Store, in the Google App Play Store and the iOS App Store. But developing an app is hard. On average, it takes about 18 weeks for a developer to build an app. All this leading to almost 65% of people never opening an app again. The space is clearly very crowded. So how do developers differentiate themselves? By building unique features and building quality. But this is often a trade-off, because the more features you build, the more you have to worry about things like scale, performance, and reliability. And the more you focus on quality, the longer it takes for you to get to market. So I really like this slide because it shows you the tip of the iceberg, where the part above the water represents the time spent building unique features. And all of that below is actually spent in managing your infrastructure and tools. We believe this is a problem. And that's why at AWS Mobile, we have the fastest way for you to build apps that scale. Up to now, previously we were supporting iOS and Android apps natively out of the box, but just on November 21st, we launched support for web, so these are progressive web apps, as well as hybrid apps like React Native apps, adding them as first-class citizens to the AWS mobile platform. Now, developers can build with us in 3 simple steps. So you start with an app. You create an app, either an iOS one, an Android one, web app, or a hybrid app. So you set up your backend with Mobile Hub and AWS Mobile Hub and the newly released AWS Mobile CLI. So what Mobile Hub and the CLI do is that they help you easily configure underlying AWS services without having to go to individual consoles and actually set up your core services for your app. Once that's set up, you actually use the native SDKs and the newly launched AWS Amplify library to actually connect to your backend, to have your app now working with AWS. So actually, let me jump right in and show you how to develop a cloud app. I'm going to start with a completely local app. So this app has no cloud features. I built it in Android Studio this week. So in the first half of the demo, I'm going to show you how I'll take this app and add authentication to it, and just actually show you how easy it is to build with AWS Mobile Hub. And in the second half, I'm going to show you how I link this app to GitHub and then build it in the cloud and share it with the testers, or continuous integration. If you want, after this session, you can follow this tutorial online at the following link. All right, so let's get started. So when I sign into the Mobile Hub console, I have 2 options. I can either, if I already have an app, I can create a project. Or what we've recently developed we've recently added to our platform are starter kits. Now, starter kits are for people who are just starting out who don't have an app. So it basically it helps you start from scratch. So with one click, you can actually configure an entire backend, and we also give you client code. So you can have an app up and running that's connected to the cloud in under 10 minutes. So just an example with the restaurant ordering app we have here, which is a web app. We set up authentication, give you a database, so you have all your models and your tables set up. We have serverless functions also set up. So we do all this for all the heavy lifting for you, so you don't have to actually worry about it. But for this demo, since I already have an app, I'm actually going to go ahead and create a project. And since I'm building an Android app, I'm going to create a project that is an Android app. So now back to the 3 steps. So the second step we have, now that I've created an Android app, the second step I have is that I have to set up my backend. When I first create a project, Mobile Hub automatically creates a cloud backend for you, and this cloud backend is represented in a cloud configuration file, which actually contains information of all the services you've configured. So at this point, when you just created a project, we enable analytics for you by default. But so that's what's in this file at this point. So we take this file and we put it into your app. So this is my IDE here. I'm adding this file into a raw folder because that's where I was told to add it. And by doing this, so think of this configuration file as a bridge between your app and the SDK, which we're going to look at in the next step. Great, so now that we've set up our backend, it's time to actually connect to the backend. And we do this with a mobile SDK. Now, because the mobile SDK uses the cloud configuration file, we can actually establish this connection between your app and the SDK really quickly with very few lines of code. As you can see here in the steps to set up, we're going to be adding a few lines of code into our app. So right there, so notes list activity is my starting activity. So just with that one line, AWS Mobile Client.get instance initialize, I'm able to establish a connection with my app. And let me show you what that looks like. So just by adding that one line, I get a log in my messages, in my logcat, telling me that I am now connected successfully. So the whole idea of creating a project is actually to first take your app and to show that you can connect it to AWS really fast. So configuring other services like authentication, which we're about to do, follows the same flow. So you first set up your backend, and then you connect to your backend with the SDK. So let's actually go ahead and take a look at how we do that with user sign-in. So once we have created this project, here's a representation of your Android app, and there's your backend. And because we configured analytics for you by default, analytics will always be in your app. So actually, let's go ahead and add user. So here are the other features you can add to your app. So you have user sign-in. You have NoSQL, Cloud Logic, which are your serverless function, user data storage, and bots. So let's actually go ahead and now try to configure user sign-in to add to our app. Now, just through a console with a couple of clicks, I can actually configure my backend. So here I'm choosing email and password. I can set up things like multi-factor authentication. I can set my password minimum length, decide what I want. So here I pick just lowercase letters and numbers because I want to keep it easy. And I create a user pool. That's pretty much it. My backend's set up. But at this point, now because I've configured my cloud, I still need to add that configuration file to my app. because our configuration file is updated, I need to now go and re-download that same configuration file and put it back in my app. This is because we just added user sign-in, and now that file is updated with information on information on Cognito, which is what we use for user sign-in. So once I'm done that, the next step is the same thing. So now I've got to add the SDK to my app. So we use the auth SDK to actually we had to write a few lines of code. And as I said, this is within like 3 to 4 lines of code, we're actually going to get a fully functioning app. So that same Notes app I showed you that was completely vanilla, was a vanilla front-end app, will now actually work with 3 lines of code. So let me just quickly show you where that code is. Right, so I have a starting activity, which is a sign-in activity, and I'm able to, with just those 5 lines of code, get a sign-in activity working in my app. It's actually pretty cool. So let me actually show you now what that looks like. So that's my emulator running. So with the code I showed you previously, those 5 lines of code gave you fully functional sign-in UI. So I can do things like I can create an account. I can, it has forgot password functionality. Just for the purposes of the demo, I'm going to quickly sign in and show you things like sorry, I think the Wi-Fi is not working, which is why. Cool, great. So just with a few lines of code, I was easily able to sign into my app and have a fully functioning app. So now that my app is working, right, how do I share it with others? So how many of you here aren't familiar with the idea of continuous integration? Okay, great. So continuous integration is the basic idea of continuous integration is to build and integrate code into a shared repository several times a day. The reason being, this is a very common experience I've had as a developer. I add a feature, I build a feature, it works on my machine, but then the moment someone else gets access to it, it doesn't work. Case in point, my demo. So the whole idea to have continuous integration is so that other people can have access to the builds, and there are a lot of benefits for that. If you're going to fail, then fail early. So it points out problems really quick because your builds are now sitting in the cloud and people can get access to it, so it points out problems. It enables automated testing because all your builds are sitting on a server. You can actually pull those builds off. You can pull the builds off the server and actually run automated tests on real devices. I'm going to talk a little bit about that towards the end. Flexible release options, because now you're running continuous builds again in the cloud. You can you can choose which build you want to release to production, and it really is a way for you to monitor quality of your app. And here's how we're going to do it. So we're actually going to use AWS Code Build to do this. So what I've done is I put my Notes app on GitHub. Right, so AWS Code Build is a service that actually will connect with GitHub, pull the source code, build it in the cloud, and once it's built, it'll put the app into an S3 bucket, the app or the artifact. So let me show you how this is done. Hopefully this works out better than my last demo. All right, so this is a project view for AWS Code Build. So as you can see, I've linked my source code, my source repository to GitHub. Right? I've said rebuild every time a code change is pushed to the repository. What this means is every time as a developer, when I update my code and I do a git push, Code Build will automatically pick up the change, build it in the cloud, and then put the artifact in an S3 bucket, which I've specified here. So all this gets set up, and this is, all right, I'm back in. Thanks. Yeah, so as I said, this is the S3 bucket where the app will go into, and it's pretty cool. So what I can show you, let me show you how that'll work. So as you can see, I've run a bunch of builds before, but we just made the changes to my project. So as a developer, if I just do a simple git push, which will take my Notes app and push it to GitHub. All right. So now what we should see, so you see a new build is kicked off right here, which is in progress. So this is all I did all I did was push my code up to Git, and Code Build picked it up and has started a test. Now this test will take a few minutes to run, but at the end of the process, what I'll get is, imagine you've built this app and you have a bunch of testers, and your tester will now get will get a notification that your Notes app is a new version of your Notes app is ready. Download it and download it to build it and test it. So this is really kind of cool, because from one command as a developer, you just push it, and other people are able to access your builds, and you can really focus on quality. All right. So how did I do that? So this is the sequence of things, the sequence of services I used in order to do that. So I to push the update to GitHub, right? I had AWS Code Build, which I showed you. AWS Code Build was set up that when it built, the artifact would then be put on an S3 bucket. And after that S3 bucket, I actually, every time something gets posted to that S3 bucket, I had a Lambda function that would take whatever new items are in that bucket and send an email to testers. So the Lambda function would use a service called Amazon SNS that would then send emails to all the testers who are registered. And what you can also do is, besides just automating and alerts, you can also automate testing. We have a service called AWS Device Farm. So Device Farm actually lets you automate, lets you set up tests on real devices. So a big pain point for developers, especially Android developers, because of the fragmented number of devices that you have in the market. A big pain point is that you're not able to test your app on different devices. Device Farm is a service that kind of gives you your app devices in the cloud. So with the same setup, you would be able to, every time you run through a build, the build will then get pushed to real apps where you can run automated tests, or if you don't have any tests, the Device Farm also has something called a feature called fuzz tests that actually goes and clicks through different screens in your app to give you feedback in terms of app crashes, what layout issues are, etc. So that's what I have so far for DevOps. So if you take a step back, I started from a simple app. I added, I cloud enabled it. I then built it in the cloud, and then I had to the final stage where I was able to share it with testers, and I was able to even able to automate it with I was even able to automate it with Device Farm. Thank you. Any questions? So yeah, currently we support Android for the cloud builds, but we do support iOS for cloud testing right now. So if you were to run this last screen, AWS Device Farm supports iOS testing right now. The cloud build currently is we only support Android. I'd love to talk to you after this. If you want to come ahead, and I can share a little bit of our plans with you. Sure. Okay, the question was, were there plans for iOS builds? Sorry, add another hand. Sure, the bit.ly URL. Sure. I'm sorry, can you repeat that? Yeah. Yeah, it is super easy to cut. So that's the pre-built screen we give you because we have a pre-built UI. But if you follow our docs, as just right in the next steps, we tell you how to customize that UI. You can do a bunch of things. You can change the background. You can change the font. You can change colors. You can customize that screen, or you could like not even use that and create your own UI. Yeah. Right. Yeah. Sure. Talk about iOS. Um, right. I think sure. So in terms of iOS, iOS builds we have iOS devices in the cloud, so it's definitely something that we're interested in. We get requests for that from customers as well. So it's definitely something we're very keen at. We're looking at very very closely right now. Well, we have a AWS device farm fleet where we have Macs in the cloud. It's just currently at this point we only support Android. I can't comment on what we're going to have in the future, but I mean it's something that we're getting a lot of feedback on. So yeah. Yeah. You can load it to your own. So for this example, I'd used a public GitHub repository, but you can actually link it to a private GitHub repository as well. Yes. Oh, a private Git repository. So I think with AWS Code Build right now, we support GitHub, Code Commit, and S3. I don't think you can at this point. I don't think we support a private Git repository. No, just a private Git repository, self-hosted. Oh yeah, you support that. Yeah. So private GitHubs are definitely supported. Yeah. Right. Yeah, I'm familiar with CloudFormation. So that's a good question. So the question was like, what if I got the question right? What's the advantage of Mobile Hub over CloudFormation? Right, essentially, basically. I think CloudFormation is super powerful because you're able to configure a lot more services. I think of Mobile Hub as kind of an easier version of CloudFormation. So we are actually have the ability. So some of our services like Lambda, for example, is built on top of CloudFormation. We're trying to make it really easy for people who are new to AWS to actually build with that. I really think the advantage Hub has is that it makes that process really easy because it's a tool for someone who's relatively new to cloud development with AWS. So in terms of so I guess Firebase would be an alternative in the Google GCP. Sure. So right now that's something that's we've talked about doing that in the past quite a bit. So uploading directly to the Play stores, but the Play stores keep changing their rules around like around like how around deploy. So we don't currently have that ability. So developers after the build, you're going to have to manually publish it to the Play stores. Okay. Yeah, API Gateway works with this. So we have API. So Cloud Logic, which was one of the tiles there, that has basically we combine API Gateway with Lambda. So API Gateway does work with this out of the box. Well, in terms of web app support, right now we did the Amplify library. So the question was, any plans for Angular? Why React? React was just the first one we kind of picked, but the library actually supports multiple frameworks, and like yes, we have so the AWS Amplify library is an open source library, so we definitely have plans to support more frameworks. Right. Hmm. Why React was chosen first? I think we looked at the community sizes, and based on that decision was made, and that's kind of how that decision making went. Any other questions? Yeah, sure. Oh yeah, that's the AppSync. Yeah, unfortunately, I can't show you because it's AppSync is in preview right now, so I don't have it. I don't have access of it on my machine here. Yeah, currently it isn't. AppSync is offered as its own service, so it'll be offered as its own service. But yes, I mean, there will be links between, because it's a tool for mobile developers as well. So right now, even if you go to the AppSync website, there are starters you can use. There's a web starter, and a React starter, I think. React Native. Yeah.
Is the iOS part of this Objective-C, Swift, or both?
So it's both Objective-C and Swift. Yeah. So we have a lot more support for Swift currently, but we also have Objective-C support. The SDKs support both. Any of you here mobile developers? Yeah. Are you guys currently building apps, or do you have apps? Yeah. All right, great. Thanks so much, guys.